Okay, in this short lecture I'm going to show you how to do a bitwise shift, and the operator that we use for that is as follows. There are two of them. One is the shift to the left. I'm going to do that just to make it a bit more obvious. Or sorry, it's the shift to the right, and that's two greater than signs, and then the shift to the left is as follows. It's two less than signs, one straight after the other. Okay. Now, these are used to move binary bits to the left and to the right, which is very useful in embedded systems. Most microcontrollers and so on, and assembly language programmers would have an assembly language instruction for either doing a rotate or doing a shift, because they're very useful. They're very fast, and they allow us to effectively do a multiply by 2 or a divide by 2 very quickly, as well as doing other operations that we may want to do. So what I'm going to do is I'm going to show you an example of a number, and I'm going to show you the number in hex and in binary. So I say 0x, and I'm going to say 0 0 0 0 0 f 0 0. Okay. Now, the reason I've given so many hex digits is because of the fact that an integer in our C programming language is going to be 32 bits long. So we have 8 digits, or 8 letters here, or numbers, and each one of those is 4 bits, so that would make 32. Now I'm only going to show the bottom few bits, which is this section here. So in binary, so I'm going to say 0 f. Now I'm afraid something has gone slightly wrong with the software that controls my my graphics tablet, so that's why everything is looking a bit funny and I'm not able to write exactly correctly. I tried to update the software and it made a bit of a mess of it, so hopefully try and get it sorted. So an F is all ones and 0 is all zeros, 4 zeros. Okay. Now, if we do a shift of one place, so what I'm going to do is I'm going to shift everything to the right in this direction by one place. I would do that effectively by as follows. If I give this this variable name here, I'll call this num. So num equals that. If I say num is assigned num, and I want it shifted to the right, and I want to just shift it by one place, so I'll put the number 1 there. Okay. Now what will happen is that this 0 will pop off the end here, this 0 will go into this position, this one will go into this position, this into this, and so on. Eventually, until we get to here, that 1 will go in there, and each one of those will move down, and then this 0 will go in there. So we'll be left with, and by the way, from the other end, it will be zeros that will get replaced in this side. Okay. So in effect, what we will have is the following. At that stage, we get a 1 in there, and then we have another 3 ones, 1 1 and 1, and then a 0 gets replaced in there, and then we've another 4 zeros here, and it's all zeros from there on in for the other 4 as well. Now, what numbers do they correspond to? Well, you can check those on your calculator or otherwise, but I tend to know them off, a lot of them off in my head. So that would be a 0 in hex. That will be in either in hex or in decimal. This will be a 7. This will be an 8, and this will be a 0. And so what we should find when we print this bit out here, that we get a number that is 0x78. Okay, so we're going to try that. As you can see, I've been playing about here with some of the numbers, so I'm just going to comment out that one there for 1 second, and comment out that as well, just to show you what we're going to do here. So you can see I've said 0000 0F00, and we'll just print that out first of all, just to show you that. Now, as you can see, it doesn't show the leading zeros on that, and if we want to see the leading zeros, what we can do is we can say that we want 8 places first of all, so we can put %8x. That'll show us 8 places, but it hasn't put zeros in for them, so we'll also put in 08 like that to tell it that we want zeros as well, and that has now printed the whole lot for us. Now, what happens when I do a shift by 1 here, and then print out the thing again? So again, I'm going to say 08, and hopefully my calculations have come out correctly, and they have indeed, and you can see now it shows 0000780. Okay. Now, just to give you another example, what I'm going to do is I'm going to change num here for one moment to a number that you might recognize. So I'll just give it the number 8, and I'm going to give that as a decimal number because I just want to show you what's going to happen. So what I'm going to do is I'm going to change these to %d so that we can see them as just an ordinary decimal number. And I want you to notice what occurs when I do the shift by 1. And we can see that what has occurred is we start off with an 8 and it changes it to a 4. If I was to do a shift by 2 places, it would become a 2. So what we find is that every shift to the right by 1 place is effectively dividing by 2. Okay, and if we swap this around and shift it this way, and again we'll just shift by 1 place, we can see that we've gone from 8 to 16. If I shift by 3 places, that would be multiplying by 2 3 times, so that would be 8 would become 16, would then become 32, and then twice 32 would become 64. And that's what's happened there. So you can see that it's another way. Now you might say, well, why would I do that rather than just dividing or multiplying? Well, in actual fact, on most microcontrollers, this operation is much quicker than a divide or a multiply, and that's the reason that we would often do it, particularly if it's something that is a power of 2. Okay, just to show you why that worked in particular. If we take the number 8, it's 1000, as I showed you here. If I shift that, that becomes 0100. In effect, everything moves down in that direction, and a 0 comes in from there. So we're left with the number 0100, and if you check that on your calculator or on a table, you'll find that it's the number 4. Okay, and that's effectively because we've moved 1 binary place. The binary, each binary place is a power of 2 from the previous one, and therefore that's why that happens. Okay, now I'm just going to show one last example. What I'm going to do is I'm going to pop back to where we were originally. So I'll just do a little bit of removal of stuff here. And what I'm going to do this time is I'm going to do a shift by 4. And what we should see happen in this case is that 4 of these move in each case. So in effect, it's every set of 4 will now move, so I'll be left with 0, 0, 0, 0, and that's because this set of 4 has now moved into this position, and it's given us the same answer. But now this set of 1s is going to move into this position, so I'm going to get 1, 1, 1, 1. This set of 0s here will now move into this position, 0, 0, 0, 0, and off the end of the thing here, we'll have another set of zeros will move into this position, so that'll be 0, 0, 0, 0. So what we should now find is that we now have the number 0, 0, F0, and of course we have another 4 zeros off the end here that we haven't shown because it's just a little bit too long to write all of them. Okay, so we'll just give that a go. So a few things that I need to change back. I need to change this back to 08x and do the same down here. change this number to 0x, and we said we're going to shift it by 4 places, and we're shifting it to the right. And I obviously didn't put in the percentage here. Okay, so if you heard the text message go off, that was on my phone, not on yours. Okay, it happens to be sitting here right beside the microphone. So we can see now that what has occurred is that we've started off with a 00000F00, and that is now, the F has fully shifted one place, which is exactly what we predicted from here, that F would shift down to this position here. Okay, so that's the shift operator, and what you'll find is that it actually pops up on a number of occasions. So if you're struggling with some of the questions that are following this video, it may well be that the shift operator comes in somewhere where it can be quite useful. So keep an eye out for it. Okay.